For numero uno, we're only going to do 3 problems because it's going to be like time consuming to have to like copy this from scratch, because I'm out of copies. And also the workbook, I don't know if I said this, I don't plan on using the workbook every single day. It's kind of like, it's the end of the month, I'm out of copies, so we have to use the workbook. So I'm going to use the workbook as least as possible because most people don't really like the workbook. So if I can make copies, I'm going to make copies. If I can't make copies, then we'll use the workbooks, but we're not going to be using it every single day. So we're going to say if triangle ABC has vertices, which means corners, A, which is -3, 1, B, which is at -7, 6, and C, which is -2, 3. We basically want to find or determine A prime, B prime, and C prime if it is translated three units right and 5 units down. So for the first problem, we're going to draw the graph using the graph paper that I provided you. The other problems, we will do it without making a graph. So whenever you have this on your EOC, you could, when in doubt, draw it out from scratch. It's a little time consuming, but whatever you got to do to get the right answer, right? Who cares? So we're going to make a graph, and because there's positive and negative numbers in my coordinate point, I'm not going to just make quadrant 1. I'm going to make all 4 quadrants. So we're basically going to make like a big plus sign. So you should have a ruler somewhere near you. So I'm not going to exactly count them if you really want to. We're basically doing like a 5 by 5 by 5. Actually, we're going to need a little bit more as we went to -7, but I'm just drawing a line. And then I'm gonna make a massive plus sign. And then make sure you're actually using the lines because somebody during first period, like made their lines for their graphs in the middle of the box. The whole point of the graph paper is that you're using the graph to make the graph paper. Like, so don't get stressed about actually counting it if you don't want to. What? What's wrong? Oh, I thought there was a problem. And then it's just the title, 4.1 translations. And then we're gonna plot the points. So take a second, catch up because people are still copying. If you're done with making your graph, then go ahead and plot your points from your problem. Remember, when you're plotting a point, you go side to side first, and then you go up or down. So point A is at -3, 1. So starting at 0, 0, I'm going to go left 3, and then I'm going to go up 1 and put a little A next to it. So -3, 1. So A is right there. B is -7, 6. So you're going to the left 7, and then you're going to go up 6. So B is up here in this corner. And then C is -2, 3. So once again, starting at 0, 0, if I go left 2 and up 3, 1, 2, 3, here's C. And then it kind of looks a little funky, but it is a triangle. So take a second, make sure you can connect your sides to make a triangle. And then literally from middle school, the same exact thing, because today's kind of like a review. First, we're going to review all the ones from middle school, and then we'll tie them all together and do combination of transformations. So if I have to go 3 units right and 5 units down, literally all I'm doing is so basically this is the problem that would be given. I'm going to take every single coordinate and I'm going to shift it exactly the way it says. So first thing I'm going to do is go 3 units right, and then I'm going to go 5 units down. I'm going to the right, and then I'm going down. So starting at A, we're literally just going to use the graph and we're going to count the little spaces. Remember, you don't count where you started. If you're running a lap in gym class, you don't count one lap when you start. People always count this box. They're like, I won. And then they go 2. You can't count 1 until you like to where you're going. So the first thing is 1, 2, 3 to the right, and then I'm going 5 down. So 1, 2, 3, 4, 5. So I should end up right here. So you're going to do that with every single coordinate point. You're just going to the right 3, and then you're going 5 units down. Do you remember this from middle school? Yeah, kind of, maybe. Maybe not. Meh. So we're going 3 units right, 5 units down. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5. So whenever you're doing these translations, it should not change the shape or the size at all of the picture. The picture should look exactly the same. If your shape looks funky and it does not look like the original, you plotted probably 1 point wrong. So when you reconnect these, and the little exponent, it looks like a little exponent of 1, it's called the prime, which means the new or final answer. So it's like where it's going. So your B is the original, B prime is the actual answer, because they're going to put both on a picture and they're going to like want you to describe what happened. And you need to make sure you're going from B to B prime and not B prime to B. So the little exponent of 1 is the actual final answer. So on your EOC also, will have you type in your answers. So if I have to type in my answer, I basically need the coordinate point. So the original A was at -3, 1. Where is A's prime's final answer? Zero, -4. B prime. Huh? You're confused? Well, that's because you're trying to multitask. Do your test. Because this is very easy and you'll pick it up. So -4, -1. And then C prime, 1, -2. So these are your answers. And then sometimes they'll have you like, most of the time they'll have you type them out in for the EOC. Huh? Oh, it's +1. I'm a silly goose. You get extra credit. Wow. Yeah. Call me out my mistakes. This is -4 and I put -1, but it's +1. Good job. Well, that's like an easy one. You should like, that should be, yeah, it's a math mistake. If it's spelling, that doesn't count because I suck at spelling. But if it's like a math thing and I write it wrong, like call me out on it so you can get extra credit. I'll add it to your test. Extra credit to your test. And then I put on a little sticky note right here, and then I'll be like, nah, these are all the people that have corrected me. So far, there's only 2, but I just added them to the other test. So, okay. Let's go to number 2. So you could make a graph every single time, which is kind of time consuming, obviously. But if you're taking your EOC and you're not sure, when in doubt, draw it out, make a graph. For number 2, let's do it without making a graph. So for number 2, let's just copy the problem again. We're only doing 3 examples because I know it's annoying to like have to write all this from scratch. For number 2, we're going to say find the coordinates of x prime, y prime, and z prime. So it looks like a little exponent of 1. If, and I'm going to give you the original x, which is 5, -7. Y is at 0, 3. Z is at -5, -2. After a translation of 3 left and 2 units up. So without making a graph, what do you think we could do mathematically if we have the original coordinate points and I'm going 3 left and 2 up? Anybody remember from middle school? Or can think about what you could do with these numbers? Instead. Subtract and add. So if you're thinking about your graph, you go left and right on your X. So anytime it says left or right, that's your X value. So if I have my X, I know I'm doing something with the 3. Do you think I should add 3 or I should subtract 3 if I'm going to the left? Subtract, because left is smaller on a number line. So I'm going to minus 3. Whenever you're talking about your y-axis, that's your up and your down. So if I have my y and I'm doing something with 2, if I'm going up, do you think I would add or I would subtract? Add. Thank you. So I'm going to add 2. So for literally every single coordinate point, I'm just going to subtract 3 to the x's, every single x value, and I'm going to add 2 to every single y value. I'm going to write out the coordinate points just to like the side, so that way you see like the originals. You don't have to do this whenever you're doing it by yourself, of course. But if the original x was 5, -7, and I'm subtracting 3 to the x and I'm adding 2 to the y, if I take 5 and I minus 3, what do I get? 2. And then if I had a y value of -7 and I'm adding 2, because I'm going up, what was my y be? Negative what? -5, good, because this is x and this is y. If the original y was 0, 3, and I'm using the same rule, I'm going to minus 3 to the x, I'm going to add 2 to the y, where would y prime end up at? -3 and +5. And then last but not least, the original z was at -5, -2. I'm subtracting 3 and I'm adding 2. So where would I end up? What'd you say? -8, 0. So these are my answers. So you don't even need a graph. Realistically, you could just use what they're telling you to find the coordinate points. Or you could make a graph. How do we feel? This isn't terrible, right? We've done worse things in our life. This should be coming back to your frontal lobe, hopefully, maybe. If not, hopefully it makes sense. We're gonna do one more problem. Let's do, I need to flip my paper because I'm kind of towards like the bottom. I only have like a little bit of space. So I'm just gonna flip my paper just so I don't have to like squish anything. Thank you. Okay. Number 3, last but not least. Hmm. Oh. Hold on, I messed up. It's not JKL, because that would make sense. Tell JK. I want to do it out of order because a lot of people think like it has to be like in order for the alphabet. It doesn't necessarily need to be in order. 2 L, it's -3, 0. So the letters can be in order and they can be out of order. So don't get freaked out about that. Sometimes they'll use A, B, and C, and A prime, B prime, and C prime. The way it is listed though is the way it matches to the second triangle or shape that they're talking about. So in this case, we're given the old coordinate points, we're given the new coordinate points, and we need to write what is happening between them. So first we're going to talk about like the words, like did it go left? Did it go right? Did it go up? Did it go down? And then we're going to write something called translation notation, which is basically like the math like equation you could use to describe the transformation. So the way it's written, if I look at L first, L technically matches with the first letter in the first or like the second triangle. So L matches with A. So what's L's coordinate point? Because it's kind of out of order and scrambled. -3, 0. And then I'm comparing that to A. What's A's coordinate? -2, -2. What about the second letter? What is my second letter? J. J technically matches with what in the second triangle? B. So J matches with B. So I'm kind of like unscrambling what they said. So 2, 4, B is 3, 2. And then the last one is the last letters, which is K and C. So K is -5, 2, and C is -4, 0. So just because it's scrambled, you may have to unscramble it. These are the letters that you are matching. So I need to come up with a rule that works every single time to go from this triangle to this triangle. So if you look at your X's, what did they do to go from -3 to -2? They what? It goes up by 1. Okay, let's check for the next one. It goes from 2 to 3. Did it use the same thing? Yep. And then same thing, -5 to -4. It goes up by 1, right? Okay. So that's your X. So does that mean that they went left or does that mean they went right? They went right, technically, because you're going up. So if I went right 1, now let's look at the Y's. So I'm comparing every single Y. It should work every single time. So I have 0 to -2. I have 4 to 2. And I have 2 to 0. What do they do every single time? Not left. They're going down because it's your Y. So they went down 2. So if it says to describe it in words, this would be like in words, what's happening. You went right 1, you went down 2 because you're just comparing the numbers. The X is the left or the right, the Y is the up or the down. The translation notation part is the part that they're going to want on your EOC. So translation notation is basically the algebra rule for this. So translation notation, and you're not going to have to remember like the words. The way it's going to look is they're going to have like 2 sets of parentheses. They're going to have like parentheses and they're going to say X and Y. And they're going to have like a little arrow. And then there's going to be a parenthesis. And it's going to be kind of big. And then they're going to have like a blank. And they're going to have a blank. And you're going to have to type in to those blanks what's actually happening. Now, you can't write right 1. So mathematically, what are you doing to your X? We're plussing 1. So in the little box, you would write X plus 1 because you're going to the right one. And then for the Y is after your little parenthesis or after your little comma. How would you say down 2? Y minus 2. So it's like mathematically, how are you getting to this coordinate point? So you would have to type in that, and then this would be your answer. So on today's homework, it's going to say like you can describe in words. If you want to describe it in words, that's fine because it says words. Or you can practice your translation notation because they don't have that in the book, but that's the way it's on the EOC because they're not going to have you type in words to the EOC. Which brings me to the book. So the book we're not going to be using every single day. For today, first off, how do we feel about this? It's not terrible, right? It's okay. Meh. We're going to rip out the paper so that way you don't have to carry the books around with